This is video 2 of the Chapter 9 test redo. If you're watching video 2, the first problem you had to do was number 17. On problem 17, whenever I see this picture, it looks like this, and you got that altitude drawn in there, I know I'm using either the leg or the altitude theorem. This time, I really don't care about this altitude, only that it's there, so I can use the theorem, but I am trying to find the leg, so I'm going to use the leg theorem. On the leg theorem, remember, the leg is the geometric mean, so leg goes here, leg goes there, whole hypotenuse goes on top here, and the part of the hypotenuse adjacent to the leg goes there. So I go to set up my proportion, leg goes here, leg goes there, that's x and x this time. The whole hypotenuse, well, this whole thing, they didn't tell it to us, but we can find it just by adding 3 plus 8. That's 11, that goes on top there. The part of the hypotenuse that's adjacent to that leg that we're looking for is that 3 right there, so that goes on bottom. We cross multiply, you end up with x squared equals 33. Take the square root of both sides, square root of x squared is x. You could leave your answer as the square root of 33 since it's not a perfect square, or you could grab your calculator and take the square root of 33 and find out that it's about 5.7, and I would accept either one of those answers. That's a 5.7. The next question you had to do was number 1. Looking at the picture, it looks like we're going to again be using either the leg or the altitude theorem. This part's 4, this part's 16, this is x. That's your altitude this time, so this time we're using the altitude theorem. In the altitude theorem we do part 1 of the hypotenuse. So this hypotenuse is split into 2 parts. It's split into this and that. So we pick whichever one we want to make it part 1, and part 2 goes down here. And then the altitude goes there, and the altitude goes there. So when we go to set up this proportion, I'm going to put 4 on top right here. X is our altitude, goes in both those spots, and then the other part of the hypotenuse is 16. Cross multiply, I end up with x squared equals 64. Take the square root, you end up with x equals 8. X equals 8. So that altitude in this picture is 8. The next problem you had to do was problem number 15. Problem number 15. Problem number 15 looks like this. It's 21, that's 75. This is x. Since we know 2 of the sides of this right triangle and we're looking for the third side, we're just going to use Pythagorean's theorem. It's the easiest way to do it. So in Pythagorean's theorem, all you got to remember is that that is your hypotenuse. So it's got to be on a side by itself. That's a 75 squared over there. The other 2, it doesn't matter which order they go in. They're the legs. So I'm just going to do 21 squared plus x squared. You find each of those numbers, 21 squared and 75. 21 squared is 441 plus x squared. 75 squared is 5,625. Then you subtract 441 on both sides. These cancel out. You're left with x squared equals 5625 minus 441. You end up with 5184. And all you're going to do is take the square root of both sides. Square root of x squared is x. Square root of 5184, grab your calculator and figure out what the square root of 5184 is. Comes out to be exactly 72. So that side right there is 72. The next one you had to do after 15 was problem number 9. Problem number 9. Problem number 9 looks like this. It's a 45-degree angle. That's a C, that's a 9. Well, if that's a 45-degree angle, that's 90. This has to be 45, so it's a 45, 45, 90 triangle. In a 45, 45, 90 triangle, the side across from the 45-degree angles should be labeled L. Side across from the right angle, L times the square root of 2. We look right here, that's the side that they told us. And our equation that we can set up is L equals 9. Nothing to solve there, so all we got to do is everywhere we see L, we stick in 9. So I'm going to go right back up here, and in place of L, I'm going to stick in 9. And again, this problem, all the problems said solve for X. Well, this one's got a C as a variable, sorry about that. So we're just solving for C this time instead of X, solve for the variable. So C equals 9 radical 2. You could have used sine, cosine, tangent if you wanted to change that into a decimal form and give me the decimal answer. I'll know what it is. I'm not going to do it. But if you use sine, cosine, tangent, you could also came up with whatever the decimal form of that answer is. The next question you had to do. Was problem number 13. Problem number 13. Looks like this. On problem 13, what you had to realize was all these sides are congruent. And this right here was a right angle. That means this big shape, even though mine doesn't look like it, is a square. Well, if that's a square, then that's a 45-degree angle, that's a 45-degree angle, that's a 45-degree angle, that's a 45-degree angle. In a 45, 45, 90 triangle, the sides across from the 45-degree angle should be labeled L. Side across from the right angle, which is right there, should be labeled L times the square root of 2. So this time, our equation is L times the square root of 2 equals 22. A couple different ways you could do this. I'd probably accept the decimal answer. I'm going to do it out using the radical form. Divide by the square root of 2 on both sides. These cancel out. You're left with L equals 22 over radical 2. We can't leave that radical in the denominator, so we multiply the top by the square root of 2 and the bottom by the square root of 2. On top, we end up with 22 radical 2. On bottom, we end up with radical 4, or square root of 4. I'm going to write this up here so I can have more room. The square root of 4 is just 2, so now we got 22 radical 2 over 2. Forget the radicals even there, and just look at the 2 and the 22. Well, that will reduce down to 2 will go into 2 once, 2 will go into 22 11 times. So it reduces down to 11 times the square root of 2. That's what L is. So L equals that. Well, anywhere we see L, we can stick that in. That's what we're looking for, is that X right there. So in this case, X equals 11 radical 2. If you changed it to a decimal way back here, if you just took 22 divided by the square root of 2 and got the decimal answer and gave me that answer for X, I would accept that also. Number 7 is the next one you were supposed to do. Number 7, they give us a triangle that looks like this. Tell us that's a 30-degree angle, that's a 60-degree angle. And they tell us this is X and this is 5. In a 30, 60, 90 triangle, the side across from the 30-degree angle should be labeled L. Side across from the 60-degree angle, L times the square root of 3. Side across from the right angle is 2L. This is the one we know this time. This is one of the easy ones. We know L has to equal 5. So anywhere we see L, we can stick in 5. This is the one we're looking for, so I'm going to come up here and then place that L and we'll put in 5. So it's just 2 times 5. So X equals 2 times 5, which is 10. So the length of that hypotenuse in this case, where X is just 10. Next one you had to do was number 14. Oops. Problem 14. Problem 14 looks like this. My triangle doesn't look real good. That's 6, that's 11. We're looking for an angle this time. So we're going to have to use the trig ratios. Side across from that angle is the opposite leg. Side across from the right angle is the hypotenuse. and the other side is the adjacent. So we label it. Once we label it, now we decide we're dealing with those two sides. We really don't care about the adjacent side this time. And the trig ratio that deals with opposite and hypotenuse is the sine. So we do the sine of our angle, which is x, equals sine, that's the SO part, so SOH, so opposite over hypotenuse, 6/11. If we're looking for the angle, first thing we're going to do is grab our calculator and we're going to hit second. So on this one, you hit second, sine 6 divided by 11, close your parenthesis, and you end up with about 33.05. So x equals about 33.05. I probably round that off to about 33.1 degrees. We were looking for an angle, so it's in degrees. Next one after 14 is 16. Again, this is video 2. Video 2. Problem 16. Looks like this. You got a 67-degree angle there. That's a right angle. This is 20. That's x. So we're going to have to use the SOHCAHTOA stuff. That's your opposite leg. That's your hypotenuse. So we're dealing with those. This is the adjacent over here. We really don't care about it this time. We're dealing with opposite and hypotenuse, which again is going to be sine. No reason that I picked both these to be sine. So we do the sine. This time we know the angle, so it's sine of 67 equals opposite over hypotenuse, so x over 20. You grab your calculator and you find the sine of 67. Don't hit second this time. We just find the sine of 67. You get 0.9205 equals x over 20. Put a 1 underneath that. This is one of the nice ones because when we cross multiply this way, we just get x. When we multiply this way, you just take that number times 20. And you end up with about 18.4. 18.4. So the length of this side right here in this triangle would have to be about 18.4. The next one is number 4. Number 4. Number 4, they give us a triangle that looks like this. Forget that triangle. They give us a triangle that looks like this. This side's 5, this side's 12. We're looking for this side. We could use Pythagorean's theorem on this one, but an easier way to do it is if you realize this fits in that 5, 12, 13 family. So the hypotenuse here, where x is, has to be 13. If you wanted to set up Pythagorean's theorem, that'd be fine. You just set up 5 squared plus 12 squared, because they told us the two legs equals c squared, and you solve that. Number 19. Number 19. The word problem says if a 24-foot ladder makes a 58-degree angle with the ground. So we got this ladder right here, and it's leaning up against something, and it's telling us it makes a 58-degree angle with the ground. So I'm going to put 58 right there. And the ladder is 24 feet long, so I'm going to write that in because that's the ladder on that side. How many feet up the wall will the ladder reach? Well, this is the wall over here, so we're trying to figure out how high up it goes, so that's going to be our x. Round your answer to the nearest tenth. Since we have a 58-degree angle, we're going to be using sine, cosine, tangent. That's your opposite leg. That's your hypotenuse. Those are the only two that we really care about this time. This is the adjacent down here, but we don't care about it. And so opposite and hypotenuse, we just got done doing that. That's the sine. So we're going to do the sine of our angle, which is 58 degrees, equals opposite over hypotenuse, so x over 24. Grab your calculator and you find the sine of 58. And that's 0.8480. 0.8480. That equals x over 24. Put a 1 underneath that. Another nice one, because when we cross multiply, that just gives us x, and all we gotta do is take that 0.8480 times 20, or times 24. And we get about 20.4 feet. So that means the ladder will reach up the wall about 20.5 feet. The next one, problem number 20. Problem number 20. Says a 50-meter vertical tower is braced with a cable secured at the top of the tower and tied 30 meters from the base of the tower. A lot of people had trouble with this one, drawing it. So you got some tower there. Doesn't matter what it looks like. It's 50 meters. You got some cable that's hooked to the top of the tower. This is one you should not have trouble with all the phone towers and everything else around everywhere now. You got this cable, it's attached up here. Well, the cable's not just going to be flying off somewhere. It's got to come down and be attached to the ground to do any good. So it's attached down there, and they tell you that it's attached to the ground, and it's 30 meters from the base of the tower, which is right there. We hopefully know that the tower makes a right angle with the ground. We're looking for the angle the cable makes with the tower. Well, the cable, that's that right there, touches the tower right there. So that's the angle we're looking for. So that's going to be our x. We're going to label the triangle accordingly. That's your opposite leg. That's your hypotenuse. This is your adjacent leg. We really don't care about the hypotenuse this time. So we're doing opposite and adjacent. Well, that's tangent. So we do the tangent of our angle, which is x, equals opposite. The tangent is the toe apart. So opposite over adjacent. So 30 over 50. When we have tangent of x, that means we're looking for the angle. So the first thing we're going to hit on our calculator is second. So we grab our calculator, we hit second tangent, 30 divided by 50, and we end up with about 30, x equals 30.96. We'll probably round that off to about 31 degrees. So the angle is about 31 degrees. The last one, problem 21. They give you a rectangle. In this rectangle, that's a right angle. This is a 60-degree angle. The side's 12. Well, if that's 60 and that's 90, this has to be 30. In a 30, 60, 90 triangle, side across from the 30-degree angle should be labeled L. Side across from the 60-degree angle, L times the square root of 3. Side across from the right angle, 2L. They want us to find the perimeter of this. Want to find the perimeter, we got to find this side up here. We look right here, that tells us L has to equal 12. Anywhere we see L, we stick in 12. So right up here, I'm going to take out that L and put in 12. So this side's 12 radical 3. Well, if that side's 12 radical 3, so is this side. And if this side over here is 12, then so is this side. Now, since they want us to find the perimeter, instead of adding the radicals and the regular numbers and trying to get that answer, you might be better off to change this one into a decimal. So you just grab your calculator and you take 12 times the square root of 3. And you get about 20.8. So that side's about 20.8. This side's about 20.8. Now all you're going to do to find the perimeter is add all the sides. 12 plus 12 plus 20.8 plus 20.8. Grab your calculator, add all those up. P equals, that's 24, 44, 64, so about 65.6. And I forgot to put any units on this, but that is the perimeter of the rectangle. So turn this in, make sure you got everything worked out completely, and I'll give you whatever points I said added to your Chapter 9 test grade.